Exploring the Cosmos, a comprehensive analysis of 60 years of lunar probe missions.
Introduction.
The exploration of the cosmos has evolved significantly over the past 60 years, characterized by groundbreaking technological advancements and a deeper understanding of our solar system. This report provides a comprehensive analysis of lunar probe missions focusing on key milestones, achievements, and future endeavors in space exploration, primarily led by NASA.
Key milestones in lunar and solar system exploration. Early beginnings 1957–1960s.
The journey into space began in earnest with the launch of Sputnik by the USSR on October 4, 1957. This event marked the commencement of the space race, prompting the United States to establish the National Aeronautics and Space Administration (NASA) in 1958. The early 1960s saw the inception of the Apollo program, which aimed to land humans on the Moon.
This culminated in the historic Apollo 11 mission on July 20, 1969.
When astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the lunar surface, collecting invaluable geological samples and conducting experiments.
Mars missions.
NASA's interest in Mars began with the Mariner missions in the 1960s, which provided the first close-up images of the planet. The subsequent Viking missions in the 1970s were pivotal, offering high-resolution data about Mars' atmosphere and surface characteristics. The advent of the Mars rovers, particularly Curiosity 2012 and Perseverance 2020, has significantly advanced our understanding of Martian geology and the potential for past life, with Perseverance actively searching for signs of ancient microbial life.
Outer solar system exploration. NASA's exploration of the outer solar system commenced with the Pioneer and Voyager missions in the 1970s and 1980s.
Voyager 1 and Voyager 2 provided the first detailed images of Jupiter, Saturn, Uranus, and Neptune, with Voyager 1 becoming the first human-made object to enter interstellar space in 2012. The Galileo and Juno missions have further enhanced our knowledge of Jupiter, particularly its atmosphere and its moons such as Europa, which is believed to contain subsurface oceans that could harbor life.
Saturn exploration.
The Cassini-Huygens mission 2004 to 2017 revolutionized our understanding of Saturn, revealing complex dynamics within its rings and providing insights into its moons, especially Titan, which features a dense atmosphere and liquid hydrocarbon lakes.
Cassini's findings have implications for our understanding of planetary atmospheres and potential habitability. Asteroid missions.
NASA's Dawn spacecraft 2007 to 2018 investigated the protoplanets Vesta and Ceres, yielding critical insights into the building blocks of our solar system. The OSIRIS-RX mission, launched in 2016, aims to return samples from asteroid Bennu, enhancing our understanding of the origins of life on Earth.
Future endeavors. Looking ahead.
NASA's Artemis program aims to return humans to the Moon by 2024, establishing a sustainable human presence and serving as a stepping stone for future Mars missions.
The Gateway Lunar Command Module will act as a staging point for lunar exploration.
Additionally, the James Webb Space Telescope, launched in December 2021, will investigate the universe's origins and the atmospheres of exoplanets, while the Parker Solar Probe aims to study the Sun's outer atmosphere.
Common themes and differences. Common themes.
A consistent theme across various sources is the importance of international collaboration and advanced technologies in space exploration. The pursuit of understanding planetary conditions and the potential for extraterrestrial life remains a central focus.
Differences.
While NASA offers a detailed overview of individual missions, other sources such as National Geographic emphasize the socio-political context of the space race, particularly the rivalry between the US and USSR.
Timeline of key events. 1957, launch of Sputnik by the USSR. 1958, establishment of NASA.
1961, Yuri Gagarin becomes the first human in space.
1969, Apollo 11 moon landing. 1976, Viking 1 lands on Mars. 1979, Voyager 1 flies by Jupiter.
2004 to 2017, Cassini-Huygens mission to Saturn.
2020, Mars 2020 rover launched. 2024, planned Artemis moon mission. Conclusion.
Over the past 60 years, lunar and solar system exploration has underscored humanity's relentless pursuit of knowledge. The collaborative efforts and technological advancements continue to shape our understanding of the cosmos and pave the way for future exploration and the search for extraterrestrial life. As we stand on the brink of new discoveries,
the lessons learned from past missions will guide humanity's journey into the final frontier. References: 1. NASA. 2023, 60 Years and Counting, Exploring Our Solar System.
Retrieved from NASA website at www.nasa.gov/specials/60counting/system.html.
2. NASA. 2023, The Future of Space Exploration.
Retrieved from NASA website at www.nasa.gov/specials/60counting/future.html.
3. National Geographic. 2023, The History of the Space Race.
Retrieved from National Geographic Education's /education.nationalgeographic.org/resource/history space exploration/. This report synthesizes various aspects of lunar probe missions, showcasing how far humanity has come in exploring the cosmos and setting the stage for future endeavors in space exploration. The exploration of the cosmos over the past 60 years has yielded several counterintuitive insights that challenge common perceptions about space exploration technological advancements
and international competition in this field.
Here are some of the noteworthy counterintuitive points identified in the comprehensive analysis of lunar probe missions and broader cosmic exploration. 1. The space race as a collaborative effort. While the space race is often viewed through the lens of fierce competition, particularly between the United States and the Soviet Union, it also laid the groundwork for international collaboration in space exploration. For instance, the successes of the Apollo program and subsequent missions have fostered a spirit of cooperation that is evident today, with multiple nations, including former rivals, working together on projects like the International Space Station (ISS). This shift from competition to collaboration is somewhat paradoxical, as the race initially stemmed from a desire for national prestige. 2. Technological spin-offs benefiting Earth. Many believe that the primary focus of space exploration is to uncover the mysteries of the universe or to prepare for potential human colonization of other planets. However, a significant portion of the technological advancements made through space missions has had immediate applications on Earth. For example, technologies developed for space probes, such as improved materials and telecommunications systems, have led to innovations in various industries, including healthcare, environmental monitoring, and consumer electronics. This unexpected benefit highlights that space exploration can yield practical solutions to terrestrial problems. 3. The role of commercial partnerships. Initially, space exploration was solely the domain of government agencies like NASA. However, as the analysis points out, recent missions involve significant partnerships with commercial companies. This trend reflects a shift in the space industry, where private enterprises are now playing a crucial role in launching rockets, transporting cargo, and even planning crewed missions to the Moon and Mars. The idea that commercial interests would become such a pivotal part of space exploration was not foreseen during the early years of the space race. 4. Misconceptions about the Cold War rivalry. The narrative surrounding the space race is often centered on the technological and ideological battles between the US and the USSR. However, the contributions of German scientists, many of whom had previously worked in Nazi Germany, complicate this narrative. The US recruited key figures like Wernher von Braun to spearhead its space program, raising ethical questions about leveraging expertise from a troubled past. This counterintuitive twist reveals that the technological prowess that facilitated the U.S. space missions was deeply intertwined with a controversial history. 5. Mars as a more accessible target. The exploration of Mars has often been romanticized as the next frontier for human colonization. Yet paradoxically, the more we learn about Mars through missions like the rovers, the more complex and challenging it appears. Initial assumptions that Mars could easily support human life have been tempered by findings that show a harsh and inhospitable environment. This insight challenges the notion that Mars is a straightforward alternative to Earth for future habitation. 6. The icy moons of outer planets. While much of the early space exploration focused on the terrestrial planets, recent findings suggest that moons like Europa and Titan may actually be more promising candidates for extraterrestrial life than Mars. This revelation challenges the long-standing focus on Mars as the most viable option for life beyond Earth, highlighting the complexity of astrobiological potential in our solar system. 7. Understanding the Sun's influence. Missions like the Parker Solar Probe aim to study the Sun more closely than ever before, revealing that solar activity has profound effects on Earth's climate and technology. The counterintuitive aspect here is the realization that understanding our own star is essential not just for space exploration but for safeguarding our technological infrastructure on Earth. This connection emphasizes the interdependence of space exploration and terrestrial applications. 8. The human element in space exploration. Despite the advanced technology and robotics involved in many space missions, the human element remains crucial. The emotional and psychological aspects of human spaceflight, such as the risks and the need for human resilience, are often underestimated. The capability of humans to adapt and innovate in unexpected situations is a factor that technology alone cannot replicate, illustrating that the human experience is an irreplaceable component of space exploration. 9. The misunderstanding of cosmic time. Many people perceive space missions as rapid endeavors, especially in light of the quick technological advancements witnessed. However, most missions take years, if not decades, to plan, develop, and execute. The timeline of space exploration is often underappreciated, which leads to a misunderstanding of the dedication and patience required to achieve significant milestones in our understanding of the cosmos. 10. The role of women and minorities. While the history of space exploration is frequently characterized by male figures, the contributions of women and minorities have been significant yet overlooked. Pioneers like Katherine Johnson played vital roles in NASA's missions, and their stories challenge the narrative of a homogeneous group of scientists and engineers leading space exploration efforts. This recognition is important as it emphasizes the diverse contributions to space science and inspires future generations from all backgrounds. These counterintuitive insights reflect a complex interplay of competition, collaboration, technological advancement, ethical considerations, and the human experience in the context of space exploration. They serve to enrich our understanding of the past 60 years of lunar probe missions and broader cosmic exploration, revealing a multifaceted narrative that extends beyond mere technological triumphs. In the report Exploring the Cosmos, a comprehensive analysis of 60 years of lunar probe missions, several important aspects may be overlooked by many readers. Yet they hold significant implications for our understanding of space exploration and humanity's future. Below are some key points that deserve closer examination. 1. Interdisciplinary collaboration in space exploration. The report emphasizes the role of advanced technologies and international collaboration in space exploration. While many might focus on the technological achievements themselves, the underlying theme of collaborative efforts between nations, private enterprises, and academic institutions is crucial. The success of missions like Cassini-Huygens and the ongoing Artemis program reflect a broader shift toward global partnerships in science and exploration. Significance: this collaboration not only optimizes resources but also fosters a shared vision for humanity's future in space. It serves as a model for addressing global challenges beyond space exploration, such as climate change and public health crises, illustrating how collective efforts can yield greater results than isolated endeavors. 2. The role of commercial spaceflight. The evolution of private spaceflight companies is highlighted particularly in the context of NASA's transition from government-led missions to involving commercial partners. This shift is not just about cost reduction, it fundamentally changes the landscape of space exploration, enabling new players to contribute to scientific advancements. Significance: the rise of commercial spaceflight signals a democratization of access to space, potentially leading to an era where more nations, organizations, and even individuals can participate in space exploration. This could result in a more diverse range of missions and research, enriching our understanding of the cosmos. 3. Technological innovations and their broader applications. The report details various technological advancements, such as the development of 3D printing in space and advanced communication systems like delay/disruption-tolerant networking (DTN). Readers may overlook how these technologies extend far beyond space missions and can have transformative effects on life on Earth. Significance: technologies developed for space missions often lead to breakthroughs in fields such as medicine, environmental monitoring, and disaster response. For instance, 3D printing can revolutionize manufacturing on Earth, making it more sustainable and efficient. Understanding this interconnectedness highlights the broader impact of space exploration on everyday life. 4. The human element in space missions. The report outlines various missions but often glosses over the human stories behind them, such as the contributions of women and minorities in NASA's history. Figures like Katherine Johnson and the West Area Computers played pivotal roles in early space missions but are frequently overshadowed by male counterparts. Significance: recognizing the contributions of diverse individuals not only honors their legacy but also encourages future generations from all backgrounds to pursue careers in STEM fields. Highlighting these stories fosters inclusivity and diversity in an industry that has historically been dominated by certain demographics. 5. The political context of space exploration. While the report touches on the competitive aspects of the space race, particularly between the US and the USSR, it may not fully explore the implications of these political dynamics on global relations today. The historical context of space exploration is crucial for understanding current international collaborations and tensions. Significance: the space race was not just about technological prowess, it was also a reflection of geopolitical strategies and national pride. As we navigate the complexities of international relations in the realm of space, understanding this history can inform policies that promote peaceful cooperation rather than competition. 6. Future missions and their implications for human survival. The report outlines ambitious future missions, including the Artemis program and the Mars exploration initiatives. While the excitement surrounding these missions is palpable, the implications for human survival and expansion into the cosmos are profound yet often understated. Significance: these missions are not merely about exploration, they represent humanity's quest for survival in the face of existential threats, such as climate change and potential asteroid impacts. The ability to establish a human presence on the Moon and Mars could serve as a backup for civilization, ensuring the continuity of human knowledge and culture. 7. Ethical considerations in space exploration. The report primarily celebrates the achievements of lunar and planetary missions but might overlook the ethical implications of these endeavors. Issues such as planetary protection, the potential for contamination of celestial bodies, and the rights of future generations to explore space are critical yet often sidelined. Significance: as we venture further into space, establishing ethical guidelines and frameworks for exploration will be essential. Addressing these concerns proactively will ensure that space remains a domain for the benefit of all humanity rather than a new frontier for exploitation. Conclusion: the exploration of the cosmos over the past 60 years has been a monumental journey marked by technological innovations, international cooperation, and a shared human desire to understand our place in the universe. However, many of the report's significant themes, such as collaboration, the human element, and ethical considerations, may be overlooked.
Recognizing these factors is crucial for shaping the future of space exploration in a way that is inclusive, ethical, and beneficial for all of humanity. Understanding these nuances not only enriches our appreciation of past achievements but also guides us toward a responsible and hopeful future in our quest to explore the cosmos. 1. Technological advancements and their impact on exploration. Over the past 60 years, technological advancements have been pivotal in the exploration of the cosmos. From the early Sputnik satellite to sophisticated missions like the James Webb Space Telescope and the Mars rovers, technology has transformed our ability to gather data and understand celestial bodies. The development of advanced materials, robotics, and communication technologies has allowed for missions that were previously deemed impossible. For instance, the use of autonomous systems and rovers has enabled long-term exploration of Mars, capturing detailed geological data and searching for signs of past life. Future missions such as those planned under the Artemis program will rely on these technologies to establish a sustainable human presence on the Moon and eventually facilitate the exploration of Mars. 2. The role of international collaboration. The exploration of space has increasingly become a global endeavor, with international collaboration playing a crucial role in mission success. For example, the Cassini-Huygens mission to Saturn was a joint project involving NASA, the European Space Agency, and the Italian Space Agency. Such partnerships not only pool resources and expertise but also foster peaceful relations among nations. As we look to the future, programs like the Artemis initiative aim to include international and commercial partners, emphasizing a collaborative approach to lunar exploration. This shift from competition during the Cold War to collaboration today marks a significant evolution in human space exploration. 3. The socio-political context of space exploration. The history of space exploration cannot be separated from its socio-political context, particularly during the Cold War era. The space race between the US and the USSR was driven by a desire for technological superiority and national pride. Key milestones such as the launch of Sputnik and the Apollo 11 moon landing were not just scientific achievements but also symbolic victories in a global power struggle. Understanding this context is vital for analyzing how national policies and public perception have shaped space exploration initiatives. Today, while the context has shifted to focus on commercial endeavors and international partnerships, the legacy of competition still influences funding and public interest in space exploration. 4. Future prospects and the quest for extraterrestrial life. Looking ahead, the exploration of the Moon and Mars remains at the forefront of NASA's agenda, with an emphasis on finding signs of past or present extraterrestrial life. Missions such as the Mars 2020 rover and the Europa Clipper aim to gather critical data that could answer profound questions about life beyond Earth. The integration of new technologies such as 3D printing and autonomous systems will enhance our ability to explore and potentially inhabit other planets. Furthermore, as NASA develops a sustainable presence on the Moon through the Gateway Lunar Command Module, the implications for human settlement on Mars are significant. The ongoing pursuit of extraterrestrial life not only drives scientific inquiry but also inspires future generations to envision a future where humanity is a multiplanetary species. 1. The Apollo 11 mission 1969. The Apollo 11 mission marked a significant achievement in the history of space exploration, as it was the first time humans landed on the Moon. On July 20, 1969, astronauts Neil Armstrong and Buzz Aldrin became the first and second people to walk on the lunar surface, while Michael Collins orbited above in the command module. This mission not only fulfilled President John F. Kennedy's goal of landing a man on the Moon before the decade's end, but also represented a major victory for the United States in the space race against the Soviet Union. The mission returned to Earth with 47.5 pounds of lunar rocks and soil, which have provided valuable insights into the Moon's geology and history. 2. The Voyager program 1977.
Launched in 1977, the Voyager program consisted of two spacecraft, Voyager 1 and Voyager 2, designed to explore the outer planets of our solar system and beyond. Voyager 1 famously conducted flybys of Jupiter and Saturn, providing unprecedented images and data about these gas giants and their moons. Voyager 2 followed suit, becoming the only spacecraft to visit Uranus and Neptune, delivering detailed information about their atmospheres, rings, and moons. Both spacecraft have since entered interstellar space, continuing to send back data from beyond the heliosphere, thus extending human understanding of the solar system and the cosmos. 3. The Mars Viking missions 1975. The Viking program, comprising Viking 1 and Viking 2, was the first successful attempt to land and operate a spacecraft on Mars. Launched in 1975, both missions provided crucial data about the Martian surface, atmosphere, and potential for life. Viking 1 achieved its historic landing on July 20, 1976, and conducted numerous experiments, including the first successful imaging of the Martian surface. The mission significantly advanced the understanding of Mars geology and climate, and their legacy continues to influence current and future Mars exploration efforts, including recent missions like Curiosity and Perseverance rovers. Future outlook: predictions for lunar and solar system exploration. As we look towards the future of lunar and solar system exploration, we can expect significant advancements driven by technology, international collaboration, and the evolving role of commercial space enterprises. Based on the last 60 years of exploration, here are several predictions for the coming decades. 1. Human and robotic presence on the Moon. By 2024, NASA's Artemis program aims to return humans to the Moon, specifically targeting the lunar South Pole. This mission will not only establish a sustainable human presence on the Moon, but will also serve as a testing ground for technologies and life support systems needed for future Mars missions. We anticipate the creation of lunar bases, which will facilitate extended stays and scientific research. These bases will likely focus on extracting lunar resources such as water ice, which can be converted into oxygen and hydrogen for fuel. 2. Mars missions and colonization efforts. Following the Moon missions, Mars will be the next target for human exploration. NASA and SpaceX plan to send crewed missions to Mars in the late 2020s or early 2030s. Technologies developed for the Moon will be adapted for Mars, including habitat construction using in situ resources. We predict that initial missions will focus on establishing human outposts, conducting scientific research, and preparing for longer-term colonization efforts. By the 2040s, we may see the first permanent human settlements on Mars. 3. Advancements in spacecraft technology. The development of the Space Launch System (SLS) and the Orion spacecraft marks a new era in deep space travel capabilities. Future spacecraft will likely incorporate advanced propulsion technologies such as ion drives or nuclear thermal propulsion, enabling faster travel across the solar system. We anticipate that these advancements will reduce mission durations significantly, making interplanetary travel more feasible and efficient. 4. Increased commercial participation. The role of private companies in space exploration is expected to expand dramatically. Companies like SpaceX, Blue Origin, and others will likely lead missions to the Moon and Mars, providing launch services, transportation, and infrastructure development. This shift towards commercialization will foster innovation and reduce costs, making space exploration more accessible to a broader range of participants, including international partners and private individuals. 5. Asteroid mining and resource utilization. Asteroid mining is poised to become a reality in the next few decades. The extraction of valuable materials from asteroids could support Earth's economy and fuel further space exploration. Companies are already exploring the feasibility of mining water metals and other resources from near-Earth objects. This could lead to the development of supply chains that link Earth with off-world industries, providing essential materials for construction and fuel in space. 6. Interstellar exploration.
though ambitious interstellar exploration may begin to take shape through missions targeting nearby star systems. Projects like the Breakthrough Starshot initiative aim to develop technology to send small light-powered spacecraft to Alpha Centauri within a generation. While these missions are still in the conceptual phase, breakthroughs in propulsion and communication technologies could make interstellar missions more feasible by the end of this century. 7. Planetary defense initiatives. As our understanding of asteroids and their potential threat to Earth grows, we can expect increased efforts focused on planetary defense. Missions to study, track, and potentially redirect hazardous asteroids will become a priority. NASA's DART Double Asteroid Redirection Test mission is a step in this direction, demonstrating our capacity to alter the trajectory of an asteroid to prevent potential impacts. 8. Understanding extraterrestrial life. The search for extraterrestrial life will continue to be a primary driver of space exploration. Missions targeting the icy moons of Jupiter like Europa and Saturn like Enceladus are expected to yield insights into the conditions necessary for life. The Europa Clipper mission, slated for launch in the 2020s, will conduct detailed reconnaissance of Europa's ice shell and subsurface ocean. As we gather more data, we may increasingly approach the question of whether life exists beyond Earth. 9. Enhanced Earth observation and climate monitoring. NASA's Earth science missions will remain crucial for understanding climate change and monitoring the Earth's environment. Future missions will employ advanced satellite technologies to provide comprehensive data on Earth's systems, helping to inform policy decisions and improve life on our planet. The integration of AI and machine learning will likely enhance our ability to analyze vast amounts of data from space. 10. International collaboration in space endeavors. As space exploration evolves, international collaboration will become more critical. The establishment of shared lunar bases, joint missions to Mars, and collaborative research on asteroids will foster peaceful cooperation among nations. We predict the formation of multinational organizations that focus on the shared goals of human exploration, scientific discovery, and the sustainable use of space resources. Conclusion. The next several decades will likely see an unprecedented expansion of human presence beyond Earth, driven by technological innovation, international cooperation, and commercial enterprise. As we continue to explore the cosmos, we will not only enhance our understanding of the universe but also lay the groundwork for future generations to thrive both on Earth and beyond. The journey of exploration will undoubtedly reshape our place in the cosmos as we seek answers to fundamental questions about life and our existence.